Okay, let's look at the homework 9, problem number 6. All right, let's do part C. All right, so for A, since the determinant, it's if you look at the determinant in the previous part, determinant of A is equal to 1. And A is an orthogonal matrix, and this is going to tell you that A is going to be A is a rotation matrix. All right, and if you look at B, so matrix B, determinant of B was -1, right? This tells you that B is a reflection. All right, so since A is going to be a rotation, we should be able to compare this matrix A. So I'm going to just go ahead and write the matrix A as 1 over square root of 2, 1 over square root of 2, negative 1 over square root of 2, and a positive 1 over square root of 2, right? So you just have to compare this with a rotation matrix, which goes like cosine of theta, negative sine of theta, sine of theta, cosine of theta. Right? So by comparing cosine, so you have a cosine here. So cosine value has to be 1 over square root of 2. Right? And the sine value is supposed to be a negative 1 over square root of 2. Right? So we can just do unit circle. So draw a unit circle. Here is x axis, and here is y axis. All right. Then cosine corresponds to the x coordinate. So here, let's put here 1 over square root of 2 here. And a sine of theta corresponds to y coordinate, which is negative 1 over square root of 2. So it's right here, negative 1 over square root of 2, right? So we're looking at the point here, right there. All right, then here, this is the angle that we're looking for. So this is going to be the angle theta, right? But this is easy to find, so it looks like this is going to be pi over 4, and it's clockwise, so it's actually negative pi over 4, right? So therefore, the angle is going to be, angle of rotation is negative pi over 4. Right? All right. For matrix B, it's going to be a reflection. Right? So since it's going to be a reflection, we're looking for the line of reflection, which is a fixed point, because any point on the line of reflection will not be affected by this matrix. Right? So we are looking for here. Matrix B, so it's going to be 1 over 1 over 5 3 4 4 negative 3, right? And you apply that to this vector, say x comma y. Right, this is going to be equal to, so x comma y is not affected by this matrix. since we're thinking that this vector is on the line of reflection. So it's going to be equal to original location, original vector, right? And this will give you a couple of equations which are actually turns out to be identical. So you can see that it's a 1/5 is in front, right? First row times column, so it's a 3x plus 4y is equal to x. And second equation is actually, it's going to turn out to be exactly the same as the first, but the 4x minus 3y, which is equal to y, right? Then you can just simplify this top equation. The second equation is going to be exactly the same as the top one. So why don't you guys just simplify that? Then the equation you get is the line of reflection. All right, that's it. I hope that this will get you guys going.